Okay, this is a trig word problem that's based on actually a machining question. So here we have a metal part that's to be made, and according to our blueprints, we've got 6 holes that are evenly spaced around the center of an object, and each one of those holes has to be centered 1 centimeter away from the very center of the circle. And the question is, what are the x and y coordinates of the centers of each of those 6 holes? So I've written out the problem here to just make it a little more clear. Each hole is evenly spaced 1 centimeter from the center. Find the coordinates of each hole if the center is the origin. So what we're looking for is a pair of numbers that represent the x and the y value of the center of each of these holes if the very center of this circle is the origin. So if that is 0, 0, what are the coordinates of the rest of the holes? Now remember, they're each 1 centimeter from the center. So the one above is going to be 0, 1, because it is 0 centimeters over from the origin and 1 centimeter up. Likewise, the hole down here is going to be at 0, negative 1, because it is no distance over from the y-axis and it's 1 unit down. We now need the x and y value of the other 4. Now they're a little bit trickier, but if you look closely, you can see that, and let's just solve this first one here. You can see that that forms a right-angled triangle. And the hypotenuse of this right-angled triangle must be 1. Because if all these holes are evenly spaced around the center, they're each 1 centimeter from the center of this part. Now we need to figure out what this angle is in here to be able to solve this. If we look closely, what we notice is we've got a full rotation, and a full rotation must be 360 degrees. And that 360 degrees is broken up into 1, 2, 3, 4, 5, 6 parts. Which means that each of these angles here, let me call that angle A must be 360 degrees divided by 6. Now 36 divided by 6 is 6, so 360 divided by 6 is 60. So that angle A must be equal to 60. And if that angle A is 60, what is this angle here that bisects it? This angle that's half of it. This angle B must be 30, because it's exactly half of angle A, and angle A is 1/6 of a full rotation. So if I go back here, this angle here must be 30 degrees. So let me redraw that triangle a little bigger so it's easier to solve. We have 30 degrees here. We have a hypotenuse of 1. And the opposite side is going to be our y coordinate. And the adjacent side is going to be our x coordinate. Because as you can see, this adjacent side here is how far over we go from the origin. And the opposite side is how far up we go from the origin. So this is our x, and that's our y coordinate for the center of that hole. So if we circle this angle here, the sine of that angle, the sine of 30 degrees, is opposite, which is our y value, over the hypotenuse, and the hypotenuse has a value of 1. So that just means that y is equal to the sine of 30. And the sine of 30, I believe, is 0.5. That's a special triangle. sine of 30 degrees is 0.5. So y is 0.5, which means this is 0.5 above the origin. Now what is the x value? The cosine of 30 degrees is equal to x over 1. Look here. The x value is the adjacent side, and remember 1 is the hypotenuse. And the cosine of an angle gives you the adjacent side over the hypotenuse. So the cosine of 30 is x over 1. Dividing by 1 doesn't do anything. We can just multiply the 1 up here. We end up with x is equal to the cosine of 30. A cosine of 30 is 0.866. So if we go up here, x is equal to 0.866. And y is equal to 0.5, and that's for this hole here. So let me just draw that on a clean copy here. So the coordinates here are 0.866 over, this is how far over we go, and 0.5 up, because that's how high up we go from the origin. So if this is the origin, we go over 0.866, that's the x value, and we go up 0.5. That's the y value. Now remember, for this one, we don't go over at all, so the x value is 0, and we go up 1 centimeter, so the y value is 1. Over here, we don't go over, so that's 0. We go down 1, so that's a minus 1. Now, I don't have to solve any more triangles because we have symmetry here. You see, this triangle here is similar to this triangle here, is similar to this triangle here, and is similar to that triangle there. So all we have to do is look carefully at our coordinates and adjust the positives and negatives to make all of them work. If this one is 0.866 over, then so is this one. So its x value is 0.866. It's positive because it's in the positive direction over from the origin. The y value, however, see how we're below the origin? The y value is negative 0.5. How about over here? The origin, 0, 0 is here, remember, that's 0, 0. So the x value is negative 0.866. Negative 0.866 is our x value, and our y value down here is negative 0.5. Now finally the coordinates here. The x value is negative because we're to the left of the origin. Negative 0.866. But the y value is a positive 0.5 because we're above the origin. So that's a positive 0.5. So we now fully answered the question. We found the coordinates of each of these holes that are to be drilled into this part. So if you were using an XY table on a pillar drill, all you'd have to do is dial it into these numbers exactly. And to recap, we found that by looking at the original diagram. And so we looked at our original diagram, and we realized that it broke up a full rotation into 6 even parts. And since a full rotation is 360, each of those parts had to be 60 degrees. And half of those parts, therefore, was 30 degrees. We then applied the fact that that was 30 degrees to complete this triangle. And within this triangle, knowing that the center of each hole was 1 centimeter from the center of the part, we then solved that triangle to find that the opposite was 0.5 and the adjacent side was 0.866. And then by the symmetry of the entire problem, we managed to determine the coordinates of each of the holes going all the way around there, knowing they all had to be the same distances, 0.866 and 0.5, from the origin as you go over and up or down. But we carefully made sure the positives and the negatives were correct based on where these holes were with respect to the center.